We can do multiple things with it. Right now, for today's purposes, we're going to focus on load testing a battery. That's the only job we're going to worry about doing right now. What we need to talk about first is we have several adjusting knobs on here, and they have to do with setting the machine up. The first is our load knob. This needs to be turned all the way to the left. It will stop. And then this is our zero adjust. We'll get back to that in a minute. Down here, if you look at this closely, we have, it says starting, charging, regulator, and then diode stator. We also notice that they're red and green, blue, and red. If you look at our scales here, we have two different scales. On our amp scale, we have one that goes from 0 to 100 amps, and then we have one that goes from 0 to 500 amps. So for battery testing purposes, we're going to use the red scale. Also down here, we see that we have two scales for volts. We have one that goes from 0 to 18 volts and one that goes from basically 0 to 3 volts. Naturally, our battery is greater than 3 volts, so we're not going to be using this. So we're going to be using the red and the green scale. If we come over here and look, we have starting says we use the red and the green scale. So for battery testing, we're going to have it on the starting or number 1 position, the far left position. This field selector is going to be in the off position. And then we have a volt selector over here. We have internal 18, external 18, external 3. What I try to tell students to remember is we're testing what's inside the battery, so we're going to use internal 18. For the most part, for what we're going to use this for, we will not change these too often. The only stipulation would be is when we do charging system, we'll move this to number 2. But other than that, internal 18, load knob all the way off to the left, and on starting or the number 1 position for the red and the green scale. Now, one thing I did not mention in our lecture in there was that we need to isolate the battery, especially in multi-battery systems. If we got a single battery system, there's nothing to isolate it from. But in a multi-battery system, especially when we come to 24-volt system, if I put this on here, this doesn't even have the capabilities of reading up to 24 volts. So we need to disconnect the battery. And what do we disconnect first? Negative. We disconnect the negative first, right? Now, why did I tell you we disconnect the negative first? Okay, I will tell you, those rules go out the window when working with 24-volt systems. They're wired in series, so you still need to be very, very careful. On this machine here, both of them are black, so we need to actually look at the battery to determine which one's negative. This one closest to me is negative. So we're going to take this off, being careful not to touch anything with our wrench. Now, when we take this off, once again, because this is hooked to the other battery, there is current here. We want to make sure that it doesn't touch anything, it doesn't ground itself out. Then we can remove our positive battery. We have both of these disconnected. The battery's isolated. It's not hooked to anything. We're not getting any stray voltage from the other battery on the other side. We can hook our machine up. Which leads do we hook up first? Positive lead first. You will notice that there's some smaller leads on here that are black and red. Those are for our 3-volt side. We're not going to concentrate on those. We're going to use our larger leads. So positive first. Hook our positive lead up, then our negative lead up. And we see that we have 12.6 volts. We're right on the money, right? It's fully charged battery. Now, what was part of the next step that I said we needed to do? Zero adjust. And if you look at our amps are already setting up here at 100 or real close to 100 amps. We haven't even hooked up the amp probe. So we need to zero this out. And that's what this zero adjust is. We'll bring it down to 0. Now I said we can hook it on either one of these. We just need to be in the direction of flow. So it's going to come out of the positive through the machine and on the negative. So I'm going to hook it up on the positive. You can see the arrow on our inductive pickup here. It's going to point to the machine because it's coming out of the positive, correct? Now, this is 1,050 cold cranking amps. So what's half of that? 525. Well, we don't quite have 525, but we can get pretty close. We're going to crank it up to 500, and we're watching for what down here? And we're going to hold it for about how long? About 10 seconds. And this is something you kind of got to do rather quickly. You don't want to be kind of dilly-dallying while you're turning this on because we need to get it cranked right up to what our testing amperage is and hold it there. So, okay, so we came right down here to what? 8.4? And we never got all the way over here, did we?
Was it supposed to be smoke?
Yeah. Smoke coming out of here? Yeah. Yep. That is the carbon pile. So there's some carbon plates in there. And what we're doing is we're clamping those plates together, and that's what's using the voltage. And yes, they will smoke. Okay, especially when this machine sat around for a while and we get it out and use it for the first few times, it's really going to smoke because there's dust and whatnot in there. So that is very normal. So for our purposes here, this battery has failed the test. It did not make it all the way up. It did not hold at 9.6 volts, did it? It dropped drastically below 9.6 volts, and we didn't even get all the way to the 500 cold cranking amps, and it started falling off. So we've load tested this battery, and it has failed. Does that mean that the battery won't continue to work? No, for our circumstances here, it's going to continue to work, but it is weak. It is not working at its full capacity. So, quick recap. Quick recap is red and green scale. So on number 1, load knob all the way off, internal 18 volts. This field selector switch we're not going to do anything with. We're going to leave it at 0. Isolate the batteries. If it's a 2 or multi-battery system, we're going to isolate the battery and disconnect it. Positive, negative lead. Make sure our 0 adjust is where it needs to be, and put the inductive pickup on with the arrow pointing in the direction of flow. You notice if you look on the scale that we have a positive and negative, and when it sweeps to the positive side. If you have it on backwards, it's going to go to the negative side. I'll also show you real quick that we can put it on the negative and get the same result out of it. So you see real quick, and once again, we don't want to be loading up the battery a whole bunch of times. All it's going to do is draw more and more energy out of the battery. It's going to be rough on it. But you see, I switched it to the negative lead, make sure the arrow is pointing in the right direction, and it still sweeps the same way. Okay, so it doesn't matter what lead it's on, as long as it's in the direction of flow. Now, the last thing that we got to talk about briefly that we have not talked about is if we have a overcharged situation. Let's say we've been out running this machine and we bring it in here and we shut it off and we come over here and it's at 13.2 volts. it's overcharged. And just like if it's not fully charged, we're going to have inaccurate readings. If it's overcharged, we're going to have inaccurate readings also. We call that a surface charge. And there's a couple different things we can do about it. With this machine, we can really quick just put a couple little loads on it, which ramp this up a couple times. It's going to pull a little energy off of it. We get it down to our 12.6 volts. We can test it. We could even turn the headlights on, turn the blower motor on, turn the wiper motor on, something along those lines. Just something to use some of that surface energy. We haven't talked about charging systems yet, and it'll be several weeks before we do. But when we talk about charging systems, you'll understand why that is, why the voltage is higher. So with this machine, you can really quick turn the load knob, pull a little surface charge off, get it down to where it's adequate, and then proceed with your testing. Are there any questions?